Testing, testing. Okay, good. Okay, we're good.
Right.
Is that good? Can you hear me? Okay, so Jill, you'll be using this. You'll be using
Like
this.
me to test that? Testing, testing.
Yeah, about this distance.
Sure. Yeah. Just have only one on at a time. It just seems to not work when it's both.
You prefer the lav, right?
Yeah.
Okay.
Great.
Okay.
So it's going to be pretty well one right after the other.
Yeah, be one right after the other.
Cool.
Okay. Not a huge crowd, but we'll be okay. We're members of RASC.
And you're all. Oh, okay.
Yeah, we are all members of RASC.
Well, I can leave it to you. I don't know if we want to wait for.
Oh, just wait for a few more minutes. Just see. Maybe let people know it's happening.
Sure. Yeah. I can actually go over to follow up.
What are those little things? Are they like business cards?
Yes.
I see. They are like business cards. Yeah, cool. Yeah. Oh,
I looked at it to get the reason, but I'm just calling to see if it's okay. If I shoot on it, November.
okay.
And when it was
Oh, it is. It is. I heard that actually. Yeah. How's everybody tonight? Yes. Pardon me? So we can see the slides a little bit better. That's all. Did you want the lights up a little bit? Okay. See what they can do.
Let everybody know outside gallery that the presentation is starting.
Okay. I'll
So
just,
we'll get started.
yeah, okay. Get some people in here. Yeah, leave it open for now. Yeah. Yeah. Not all needing repair though. No. But what I'm going to do tonight is just let you know what the different kinds of telescopes are, because there's quite a variety. So if you don't have one now, then listen carefully, because you'll hear all the major types of telescopes that are available today. So I've entitled this talk "The Magic of Lenses and Mirrors," basically because to me, telescopes are still quite miraculous. So in Arthur C. Clarke's words, he actually had three laws, and his most famous law is any sufficiently advanced technology is indistinguishable from magic. And so it must have been with the development of optics. So here's a timeline. I start off on the side here with Aristotle, actually. So let's see if we can get this thing going. But yeah. Okay. I'm gonna have to switch to my other one. Thank you. Oh, not that one. I use this one. It's quite an interesting timeline. We start off with Aristotle, who actually had a pinhole camera. So he realized that he could start projecting virtual images on different surfaces, right? A little bit different from a telescope, but that's kind of the beginnings of optics. Then Euclid determined mathematically that rays of light could actually converge and produce images. And I can't pronounce his name, but he's considered the father of modern optics because he started to put a lot of this stuff into practical practice. And of course, Roger Bacon, he actually originates some of the original magnifying lenses, and that's in the 1200s. And then, of course, this is when the magic begins. So when did Galileo first make the telescope famous? Does anybody know? So that was in the 1600s, okay? So at that time, there were people already making spectacles and also using different types of, I think the microscope was around at that time as well. But Galileo did one thing that was kind of novel. He actually looked up into the sky, and that was the difference. Even though people may have been using some of these things for terrestrial purposes, so for instance, people were using the telescope to see ships coming from a distance, right? So it had kind of like a military or commercial kind of application. But as time passed, Galileo actually started recording, and there is a book called Sidereus Nuncius that Galileo wrote, where he has a diary of all the things that he looked at. And in fact, many of the things that we see today as amateurs, we looked at. We look at Jupiter, we look at the moon, we look at Saturn, all these things, but he saw it through little tiny lenses. So for instance, Galileo's scope, just for sake of argument, was a 1-inch telescope. Most people's telescopes are far bigger than 1 inch. So that's all he had to work with. And then something happened later on, and not very far later on. Isaac Newton determined that mirrors could also converge light. So that allows us to have Newtonian designs, where we actually focus light with a mirror as opposed to refractive lenses. Okay. Oh, please come in, please. We're just studying on the history part. This is the boring stuff. Okay, so what are the attributes of a telescope? Well, there's focal length. Okay, so that's the distance of a distant object coming to focus. So that's a focal length. I'll show you what that looks like in a ray trace in a second. There's aperture. Now, aperture is just how big the opening is. And then we'll come to understand that is a big factor in seeing things that are dim. You want big openings or big apertures. So focal ratio is just a ratio of those two things, and that gives us an idea of, whether something's going to be dim or brighter. And we'll see that. In fact, I think Kristen's probably going to give us a lesson in the formulas. So optical design, well, they can be refractive lenses, mirrors, just as in Newton, and then catadioptric, where it's a mix. It's a mix of lenses and mirrors. So Massethoff-Cassegrains and Schmidt-Cassegrains are like that. So they're a mix. So weight and dimensions are important. So what you're going to see, I'll probably make some notes about, which telescopes are heavier and which ones are lighter, and that might be a factor for you. It's a factor for my aging bones, so I prefer things that are a little bit lighter. And then it's also important for cases and transport too. Maybe you don't have a car that will house a humongous, 25-inch scope or something like that. Okay, so here's a refractor. This is the second telescope that I owned. I actually owned a catadioptric in the beginning, and I was a little bit dismayed by the tunnel vision that it gave me. It only allowed me to look at very, very narrow swaths of sky. So then I went to the other extreme, and I went to a wide field refractor. So this is the closest thing to Galileo's scope. So there's a set of optics at the front, and then an eyepiece at the back. So you see that light rays come in, and they converge, and they go through the eyepiece, and then into the eye. It's a very simple design. Now, Refractors do come in other designs as well, but they're a little bit more sophisticated. To overcome some of the problems that we have with refractive lenses, they actually introduce additional blocks of lenses. But of course, that's at the cost expense and also weight expense. So here's some advantages of a refractor. They're easy to transport and store, wider field, as I mentioned, and they're good for multiple stars. Like often we look at stars together in pairs. In fact, the majority of stars that we see up in the sky are actually partnered. So there are at least 2 or 3 stars in the system together. Also good for the moon and has really good contrast for planets because there's no blockage of the light coming through the refractive lenses and low maintenance. Now, this may not mean anything to you right away, but cool down, that is a factor in the sense that every time when you look at stuff through a telescope, you're actually looking through columns of air and not just out in the sky, but they're inside your tube, your telescope tube. There are currents that are at work there as well. So if you have a very large tube, enclosed tube, then you could have heat trapped in there from bringing it in from inside the house to outside where it's much cooler. So that's a downside. Now, the downside to a refractor is they're not very useful for really dim objects. So they're not going to win any awards for looking at things like galaxies and things like that. And this is the thing I told you about chromatic aberration. So basically, chromatic aberration just means that all colors of light don't come to focus in the same spot. E.g., they look fuzzy, right? So the cheaper designs are achromatic, and for very bright objects, you might see this thing called chromatic aberration. That's where the additional lenses fix that. And you're also limited to magnification with the aperture as well. Can't go much higher than maybe, I don't know, 120, maybe 200 times. So this is a Newtonian. So this is one of the first designs I'm going to show you, which are based on Newtonian optics. So basically a mirror, oops, going the wrong way. There. So basically light comes through. Now this whole area here is open. So this thing is called the spider. It just holds the secondary mirror here. So light comes through air basically here. There's nothing here. Comes through, it bounces off this curved mirror at the back and sends it down to this secondary mirror and then comes back. Oh, sorry, comes back up. So this way comes down and it directs light upwards into the eyepiece. So this is a folded system as well. So it comes down and it's folded inside this path. Now, what's good about Newtonians? Well, they're the cheapest telescope for the aperture. So if you want big aperture, you want to see things like galaxies, this is the thing for you. And it's relatively inexpensive as well. Only thing, it does require some maintenance, it requires some collimation, but it's nothing that people can't learn easily. And there's some cool down required depending on the design and the size of the mirror. And it's also more likely to be disturbed by wind. But a lot of people swear by this. You're going to have Brenda tell you about her Dobsonian, which is in essence a Newtonian design in a Dobsonian mount. So Newtonians also occur on equatorial mounts as well, but they're more commonly nowadays on Dobsonian mounts. So this is a Schmidt-Cassegrain. A number of people have this. This was my first telescope, and this is one with a narrow field of view. In this case, there is a corrector plate at the front. So this light comes through like this, bounces off the mirror just like on the Newtonian, but it comes back around to this secondary mirror and it comes way down this tube, down to the eyepiece. Now, this was all the rage in the 1980s. This was a do-everything scope that people sold in the 1980s. The downside to it, it's heavy, and it's a very narrow field of view. So less maintenance with an enclosed tube, and it's good for deep sky. Good general purpose. That's why they called it general purpose in the 80s. But longer cool down for the mirror, so you have to cool it down. And it requires collimation, but less often than a Newtonian. And it can be heavy if it's greater than 8 inches. So here's a Mastertov Cassegrain. This is the last design I'm going to show you. Now this one is interesting because instead of just a thin corrector plate, it actually has a corrector lens. So this is an inherent part of the design. And it does the same thing that the Schmidt Cassegrain does, but it does have the secondary spot here. So it's interesting because of this. Very compact designs. A lot of people find that they go down to as small as like 90 millimeters. They can be very compact. Kirsten's going to tell you about her Mac 90 tonight. So a little bit less maintenance, good for planets and moon, but very narrow field of view. And it does require a little bit of cool down. If it's a small one, it may not require that much. So these are all the designs. They get compressed. All these designs are kind of compressed designs. This one is the closest to Galileo's telescope. So now I'm going to tell you a little bit about mounts, because every telescope needs to be put on a mount. And the simplest kind of mount is an alt-azimuth mount, and I'll show you some pictures of those. Basically, this is the most easy to understand, because basically your azimuth is just your cardinal direction, and then your altitude is just up, down from 0 to zenith. So designs are quite easy to use. This Dobsonian actually is a form of an alt-azimuth mount, but only one form of it. And then the other version is called equatorial. And the unique thing about equatorial is that it actually has two axes. It has one axis that is actually pointed at the North Star. And because all stars rotate about the pole star, then this is a good way of tracking. So people like Dave, who have astrophotography needs, he would be using an equatorial mount. So here's some examples. Here's the alt-az mount. It's a very simple kind of mount. You can move it around. You can tilt it up and down. Same thing for the Dobsonian, but in a slightly different mount. Equatorial mount, there's one that's axis, and that's the right ascension. And then the top piece rotates as well, and that's called the declination. And here's the Schmidt Cassegrain in a double-armed alt-az configuration. A lot more complicated, actually. So what's the best telescope? It really is up to your needs. I know Kirsten has been asking me questions. She has her first telescope, but she's already on to the next. And of course, that's exactly what happens. You buy one, you can't have more than, I don't know, you can never have more than one telescope, I don't know, something like that. So price is a consideration, weight and size is, how much maintenance is involved, and how much prep time are you going to take to kind of look, and then how big an aperture do you want? And in the 80s, again, people always talked about aperture fever, that everybody wanted the biggest scope. And it actually really did get ridiculous because people started going into like 40-inch mirrored scopes, like humongous scopes. And then the ability to image requires tracking and good tracking. Otherwise, you can't get those really steady images. So you have to think about what you want. So, but you can mix and match, as I mentioned. Newtonians occur on all sorts of different, and most telescopes have other accessories I have not talked about. So there are things like the diagonal, the finders that are on, and different people tonight will tell you about those pieces. So I don't need to tell you about them. And the biggest word of advice, come and join a local astronomy group like RASC, like ourselves, because you get to try them out before you go and buy one, right? And I think that's really important. I think sometimes people buy a telescope and they kind of regret it because they didn't understand what it was going to be like. And best thing to do is look at other people's scopes first. So any questions? I almost used up my time now. No questions? Who's about to buy a scope? Anybody? You would like to buy a scope? Well, I know there's a lot of hesitation from people because they think these things are so expensive, and I'm not saying that they're not. I would say the used market is very vibrant right now. There's a lot of old people like myself, which are probably letting go of telescopes. So you probably get a good deal if you know what you're looking for, right? So part of this whole thing that I've talked about tonight is to educate you to see what's good and what might be good for you and what might not be good for you. So when those opportunities do come up, then you'll be able to jump on them. And also for you to determine whether something is in good shape or not. I think that's really important. But anyways, have a look at different scopes tonight and see what's available. That's the best I can say. And I think all the people that follow me tonight are going to tell you very unique experiences about the equipment that they have. I've only spoken about what's possible in terms of the designs, but everybody that follows me tonight has a story to tell about their telescope. So thank you. So I'm going to give some time to Jill and Brenda to set up. And I can give you this if you'd like. The clicker is, sorry.
The red dot.
Oh, you want to use this?
Yeah.
This is left, right, and then press the middle for the point.
Okay, left, right, middle.
Just don't point it in my eye.
Okay.
Are the rabbits part of the astronomy equipment? Oh, this is a new one. Jill is a recent member of my class. But I would have to say her observing skills are more than impressive. We have lots of badges to show for it. And most importantly, I would say, I just want to let everybody know how appreciative we are of Jen, because she's led the Explore the Universe group. Now, just to let you know what Explore the Universe is. Explore the Universe is a program that we run where we introduce beginners to astronomy. So if you've never done anything to do with astronomy, then you want to do the Explore the Universe, because you get, I would say, quite a interesting smorgasbord of things that we do.
It's very broad.
It's what?
Broad.
It's very broad.
It's broad.
Okay.
Yeah.
Okay.
Yeah, I think so.
Okay. I just.
Okay.
Great. Okay.
Okay.
So, take it away.
Okay. Thank you. And we are Jill and Brenda. I am Brenda. So I'm looking around and seeing a lot of people that we observe with. So there are a few that we don't know. So that's good. I just wanted to say why I got this telescope. And I grew up in southern Alberta, and the thing you do in southern Alberta is look up and look at the sky, because that's what there is. So I always was looking up and interested in astronomy and the clouds and everything else, but never really did anything about it. I just was always thinking I would. And then the pandemic happened, and everybody was doing different things than normal, and NeoWise was a big thing, and everybody was out on Mount Ptolemy looking at NeoWise, and I thought, I'm going to go do that. So this man came along and he threw one of those down on the ground. That's my scope. And I thought, I'd never seen anything that looked like that. So he said, anybody want to see Jupiter? And I said, pick me. So it was awesome. And I kind of remembered what it looked like and went home and I Googled it, and I actually bought one from Toronto and got it delivered to my house, put it together, played with it for about a year before I joined Rask. So I did everything off my back deck, and really had a lot of fun before I started formally learning things. I just did a lot of experimenting and learning that way. So that's how, and I just got really lucky because I didn't do a lot of research, but as it turns out, this kind of scope is highly recommended for beginners. So I just got lucky. Anyway, and now Jill will tell you her story.
Which is kind of similar in that I was always interested in the sky and knew some constellations. I could even find some deep sky objects, but I always wanted a telescope. And then when the pandemic came, I went and got myself a telescope. But I found I didn't really like it very much, and I went to binoculars, and that's what I've used for the last 3 or 4 years is binoculars. And I guess this is no, that doesn't work. How do we move it forward, David? Oh, there it is. There it is. Okay, so I mean, the attraction of binoculars is, of course, that they're less expensive. Usually, they are. I know it's terrible. They usually don't. They're very portable. They don't weigh a lot. These are completely impractical for me and for most people. You really need a tripod to be able to use them at all. And even with a tripod, it was kind of difficult. If you got a tripod, you might as well have a telescope. And what I didn't like about the telescope was the weight and the difficulty of moving it around. So I brought here some different kinds of binoculars. There are little tiny anything that if you've got binoculars, you probably have them in your cupboard, which is another reason why binoculars are a good thing to start with. These are obviously very tiny and don't do a lot, but they're not bad for the moon. These are kind of pushing, they're kind of heading in that direction, but not too badly. And these are the binoculars have two numbers. You'll see 7 by 37 or 10 by 50. The first number is the magnification, and it's fixed. If it's 10, you're going to get 10 times magnification. The 50 is the size of this lens at the bottom, and of course, as David says, the bigger the better in terms of gathering, and if you want to see small objects. These tiny guys are actually 10 by 25, so they're not going to gather a lot of light. These big suckers are 15 by 70. The 70 size is comparable to a small telescope. But they're heavy and they're awkward. And so kind of the sweet spot is around 7 by 50, or these are 10 by 50. They're fairly light and fairly accessible. I've owned these binoculars virtually all my life. I just didn't know what to do with them really, and how I could really, how much of the night sky and how many things I could see with them. I'm not a shill for Canadian Tire, but these binoculars, the Celestron, are on sale this week. It's just in this flyer. Save $120. Regular $219 for $99. Now, they are heavier, and I invite you to come up here and try them and see how you feel about holding something like that, because it's a problem if you're thinking about binoculars. So binoculars have other advantages. You get a wide field of view. You don't have to worry about things being upside down or backwards or anything like that. But of course, they have some disadvantages too, and that there's a limit to what you're going to be able to see with them. And at this point, I think Brenda should show us her telescope. And except for I've lost my little clicker thing. Ah, here it is.
Thank you. So this is a reflector, and that means I'll just gotta take this off. and it's a 6-inch. That means the mirror is 6 inches. And so this is where your light comes in, and then it goes down onto this mirror, and then it comes back up into the secondary mirror here and then out to your eye. One of the things you have to do with a reflector, which is you have to keep them collimated. So you have to keep the two mirrors lined up, and that can be a bit fussy. Some people have more trouble with it than others. But anyway, so is how you use it. You look through the finder scope, and this isn't a really fancy one. You can get this just has crosshairs. You can get a red dot finder scope that's kind of works better, but this is what came with it. So you see what you want to look at in the sky, and you find it in here, and then if this is properly aligned, you should see it in your eyepiece. And so then you focus, and you can move it like this, and you can move it like this. And it's actually pretty darn good for seeing nebula, planets, globular clusters, and not as good for open clusters because you need a wider field of view. And we're going to show you some slides later that talk about that. So one of the things I found when I first got this scope was it was kind of low for me, and a lot of people sit and use it, and I decided that I wanted it higher. So I built this stand for it. I just went out and got a jigsaw and built the stand. And I like it because I can roll it around, and I can take the wheels off if I want it to be more steady, because it is a bit wiggly, and that's not desirable. I love this little knob, which was on it, but I've never seen another one with one. And it allows you to steady it if you need to, or just to move it slightly like this. And so that works good. Then it's got these places to hold your other lenses. And the most commonly used lens, I think, for this is something like a 25. So the higher the number, or the lower the number, the more power you have, the more magnification you have. So if you use a 10, that's more magnification than a 25. So what I usually was doing was finding what I wanted to see with the 25, and then putting more magnification on it to see it better, see it bigger, or more clearly. But if you have not a good image in your 25, it's not, like if it's not clear, if you don't have good seeing, it's not going to be better with more magnification. So you're hoping for good seeing always. So yeah, let me just see what else. It's heavy. The stand is heavy. The optical tube is light as a feather. So that's no problem. But if it was any bigger than this, like this Skywatcher makes 8, 10, 12-inch scopes just like this. You probably see some outside on the deck. But it gets a bit heavy to lug around depending on how much you can weigh. So that's one thing that is not as good. It's 100% manual. Like this doesn't have anything fancy. It's just manual. So you just you have to make it go where you want it to go. Nothing fancy. So I sometimes use binoculars to get an idea in the sky of where I want to start looking, and then I narrow it. I go with the scope, and I do it that way. So I think that's just kind of it, and it's been a lot of fun. I still really like it. The images are mirror reversed, so they're upside down. So you have to factor that in when you're looking at things. Anyway, I'll turn it over to Jill. There's me on my back deck. This scope I got from Toronto from ConScopes, and it was $500. Just around 500. Yeah. And that's, I think, about what you might get less, you might pay more, but around there. So I thought that was okay.
So what we're going to do now is show you a couple of slides that show the difference between the views that you get if you have a binoculars or a telescope. This is, if you can make it out, Saturn. And Saturn, yeah, it's God, you can see the rings. You can see maybe the planets. I think that's a bit optimistic, or the satellites. But that's a telescope view. That's something that Brenda would see. This is what I would see. It looks like a fuzzy dot, kind of. And that's almost as good. It's a bit of an exaggeration. Sometimes the fuzzy dot appears kind of oval, like it has ears. But that's about it. On the other hand, this is what Brenda sees when she looks at a very famous open star cluster. It just looks like a cup sprinkling of stars. You think, what's the big deal? When you look through binoculars, which have a much wider field of view, you can see that you have the Pleiades, which is a beautiful sprinkling of stars that are all kind of connected together. So there are advantages and disadvantages of the two different approaches. Shall we talk a bit about the benefits of a target plan?
Okay, so when you're first starting out, I found it really useful, and I think it's just true. You have to have targets, or you're just out there wandering around in the sky, and so it's really helpful to have targets to know what you want to try and find to look at. So everybody probably knows a few constellations, and what you have to do is begin to learn the night sky and start finding things from the places you know. So if you know where the Big Dipper is, or Ursa Major, you can find Arcturus, and that's it's in another constellation. But you can begin to make your way around the sky to see what is in it. So probably everybody knows a few constellations, and you can start that way. So are you want to talk about Explore the Universe now? Yeah.
So this is a page from the Explore. David mentioned the VASC Explore the Universe program, which is kind of like a sampler of all of the universe's delights. And you look for planets and double stars and different constellations with their major stars and some deep sky objects. And it's a VASC program, but you don't have to be a member of the Royal Astronomical Society to do the program. And if you complete the program, and you can do it all with binoculars. That's we both, you did it with binoculars, didn't you? Yeah. And so if you complete the program, whether you're a member of RASC or not, and you submit your records, you can get this cool pin, which I will show you. But I'm going to show you, first of all, an example of Brenda's records, which are stunning, I think. There's a moon drawing, and which is some of the other star cloud in there, I think. Now, but you don't have to be a great artist to submit. I'm going to show you this was my moon drawing. So it's kind of, it's got all the stuff on there, but it looks like it was done by a 5-year-old. But it's sufficient. I mean, it's not about art. It's about doing drawings. And you don't even have to do drawings. You can just do descriptions. And then you will, if you submit your materials, you will get a cool pin. It is not that big, and that's the one I was showing you. It's this big, but it is cool. And the other thing we've got these little tags. Take one if you want. It's got the address for the Explore the Universe website, as well as for Stellarium, which is a program that you'll see that some of the slides that we're coming to, that we've taken them from it. It's like a home planetarium, and it's really useful if you're starting to explore the universe, because you can set it up for your location and your time and the direction you're looking in. Say, okay, there's whatever, and try to see if you can go out there and find it. And so I think we were just going to do a couple of examples. Some are targets.
Some examples of targets. Examples of targets that you can look at, and also I don't want to forget to talk about some of the books that are on the table. So take it away. Okay, so which one is this?
This is just the sky that you'd see if you went looking and looked roughly south at about midnight. I just want to make a point about that because right now it's getting very close to the summer solstice, and it doesn't really get dark until midnight. And you will, it's not the best time of year to take up astronomy unless you're a night owl, because there are, it's better to wait until about August. It'll start getting dark at about 10 o'clock at night, and you'll be able to see. And the darkness doesn't last long. It's under an hour that we get night right now. And as I was telling somebody I was looking with, if you're up in Nanaimo, they don't even get night in Nanaimo these days. They have various levels of twilight, and then it repeats itself on the other side before the sun comes up. So, but I'll give you the back in a sec, just that this is a shot from the stellarium that shows the lines that are used to kind of mark out the constellations. But of course, when you go out into the real world, there are no lines. That circle is the binocular field of view of 5 degrees, but and it's not there either. And the Z at the top is the zenith, which is right overhead. But that's kind of more what you're going to look at. But that's how you can use stellarium. You can practice. Okay, there's something with the lines. Take away the lines. Can I see it on my computer screen? And then when you can go out and try to see it in the real world.
Now, are we going to go to Hercules?
Yeah.
Going to go to Hercules. First, I got to find that. Do the pointer thing. Yeah. I know, it's hard to see.
Yeah, sure, it's hard to see.
Yeah, maybe. Yeah, okay. Yeah. So you go down to the last star in the handle, and you follow the line of the arc, and you find, and the star will look very bright in the night sky. So you'll find that star, and that is Arcturus, and that is in Boötes. That's in another constellation, but there's a point behind this. So there's another bright star in this, and it'll look really bright. Like you'll see them both; they're quite distinct. So how I've been finding Hercules lately is I find Arcturus, and I find that's Vega in the constellation Lyra, and draw a straight line between them, and you'll run right through the body of Hercules. That's that square flower pot thing. That's Hercules' body. Poor guy. Anyway, so in that constellation, in the body of Hercules, there is a globular cluster that you can see with binoculars. So that is a target that you could look for. And do we have a more close up of that? Yeah. There's Arcturus. And there's your other star, Vega. And there's the flower pot in the middle. I shouldn't say that. The flower pot would be an asterism. Anyway, so yeah, right in there. So you could look on Stellarium if you wanted to and see exactly where is that globular cluster located in Hercules, and then you would know which side to look on, and you could look on that constellation with your binoculars, and you could see a globular cluster. Yep. Yeah. So that's just one example of a summer target that you could look for. And this is very high in the sky right now. It's very high.
It's a smudge, but if you put Brenda's telescope on it, then you would. Oh, there we go. That was the naked eye view. This is my smudge. Here's Brenda's telescope. Take a look at this. It's gorgeous. There's 100,000 stars there, and she can actually make some of them out. Whereas I see it's better than Saturn. That's all I can say.
Right. So that is just an example of one target that you could look for. But now I think, are we going to Sagittarius? So there's a really exciting constellation in the south sky, which is only around in the summer it's about a good month at least, I guess. But it's kind of in the shape of a teapot. We look for the teapot, and you have to have, be able to see quite well into the southern sky. Anyway, there are an amazing number of deep sky objects in the constellation Sagittarius. And you can see them, some with the naked eye. You can see them very, very easily with binoculars. So there's open clusters, globular clusters, there's star cloud, there's nebula, and I don't know, there's quite a few of them. That would be a good one to look for also. It's really exciting.
So this one is M8, sort of naked eye with binoculars, and then watch what's going to happen here. No, this is the telescope view. It looks spectacular, doesn't it? It's upside down. That's the first thing you might notice, is that north is where south used to be. That's binoculars. Here's telescope. But you also get all this color, and you won't get all this color. The reason that there is this color is because it's a photograph, and it was exposed probably over hours of the photons hitting the, film or the plate or the whatever, however they do it. And our eyes can't process things quite that effectively, so it'll look gray, gray and white, kind of, more.
Well, and I just think you can get in some nebula a bit of color with a scope about this size, but you don't get a huge amount. Like, this is enhanced. So it's pretty exciting, but it's not that exciting. Anyway, we get excited when we're out there looking because there are so many things to look at in Sagittarius. It's really wonderful. Okay.
That concludes our presentation.
Okay, I'll talk about the books for half a second here. So these are really good introductory books. I think everybody should have this book. It's Night Watch. And the fellow Terence Dickinson, he just passed away about 2 years ago, but there are many editions of this book. And it's got charts and information, just all kinds of stuff. It's a really great book. This is our Explore the Universe, that program we were talking about. This is something you get with RASC. It's the Night Sky Almanac for month to month and day to day, whatever is happening in the sky, where the planets are, and all that stuff. So come and look at the books and grab one of these, where this has the websites and things you can look at. Okay. Thank you.
Great. Well, thanks so much. Any more questions? We're about to move into the non-visual stage. So that was actually a good segue when they showed us that image of nebula, because we would never see that with our eyes, because our eyes only see with a particular wavelength in the green and visible spectrum in the middle of the spectrum. What we're seeing there is accumulated light based on photography. So that's what we're going to see next. So this is one way of extending the vision of astronomy beyond our eyes, is to use photographic means. So David's going to do that, and we're just going to get him set up. You prefer that? I'm going to turn this on first.
Check.
Just going to set you up.
Oh, okay. The clicker.
Is that it?
Try this one, see if it's working. Press the top one, let's see if the spotlight's working. Okay, I need to resync it. Oh, there, it's good.
Okay.
How's that?
A bit of feedback. A lot of feedback. Hello, check. Can you hear me good? Sounds great. Okay, I'm going to talk a little bit about astrophotography. There's a lot of gear you can spend. Well, you can spend whatever you want to spend on this hobby, and I probably overspent. But there's also ways to do it very inexpensively. extensively too. What I recommend is that you start off simple, and if you get into it, then gradually develop, get more gear, and incrementally improve your photography. But don't jump in with both feet is my big recommendation here. But I'm going to talk a little bit about the gear and a little bit about options and what you can do there. So the basics, two things that you need to do astrophotography, just like any photography, is you need a camera that's a sensor that records the light hitting it, and you need a lens, something to gather the light onto the sensor. And I bet everyone has those two components because they build them into phones now. And I'll talk a little bit more about that. Or you may, if you're a little bit more old school, I used to take a DSLR camera when I go on holidays. I don't do that anymore because I've got my phone. It takes great pictures. But if you do have one of these, you've got everything you need to get started. So the first thing about astrophotography is just about everything, the moon being an exception, the sun being an exception, but just about everything is dark, okay? And what that means is you want to take your camera, and usually there's an aperture control. You want to open it right up because there's a little gizmo inside here that closes and opens to control the amount of light. So if you're taking a picture of a bright object, it'll close. So you want to open your aperture as big as your lens allows. So you want your lens to gather as much light as possible. You can change the ISO, which is the gain of your camera, the sensitivity of your camera. But the higher you put your ISO, the more noisy your picture is going to be at the end of the day. And then the third thing that I highly recommend, if you've got one of these already, is get, oh, I'm missing a slide there. Is get a tripod over here. So it's holds the camera steady, and you can take great pictures with just a tripod. I've also got, you can see dangling from the camera there on the tripod, is one of these things. And basically it's, it'll open and close a shutter. These are about $100. You got to get one that's specific to your camera from a camera. And so what you can take is very long exposures without any jittering of the camera if you held it yourself. Oops, wrong button. So most targets are dark. What you'll find is there is some processing when you get the image out of your camera. It'll look something like going the wrong way. Got the buttons mixed up. Sorry about that. It'll look something like that when you get it out of your camera. If you load it up onto a computer, there's lots of free software that will allow you to brighten up the image, and what you're taking a picture of will actually appear for you. Here's another example of a little longer exposure. You have to brighten it up, and you can see that you've got a nice picture of the. So there's generally processing that's involved. But if you've got a PC or a Mac or something, that's easily done. The second problem is, even if your camera's steady, the stars are moving in the sky. And if you're trying to take a picture of a star, you'll get them circling around the North Pole up here. So you'll see if you leave a car, it makes for a neat picture, but if you're actually trying to take a picture of something in the sky, well, that might not be the effect you want. Similar on the right side. right side. So stars are rotating around the North Star, and that's due to our rotation. Really, it's us that's rotating. The stars are remaining essentially fixed. So it's because we're rotating. But what you can do then is the next step to get rid of something like that. It's something called a star tracker. Sounds sky tracker or star tracker. Sounds very sophisticated. This one, what it is on a round pulley mechanism attached to a motor. And when you put it on here and you point it in a certain direction, and it will turn as the stars turn. So it'll take that effect out. And you can take great pictures with one of these star trackers. A tracker might be, if it's ready-made, it might be a couple $100. This one was 3D printed. You can, if you into 3D printing, which is one of the nice things about this hobby, if you're into tinkering, it's great. You can always buy things pre-assembled, but if you like tinkering, you can save some money. So the tracking device will follow the stars around the pole, and you can take great pictures with your camera and some fairly inexpensive equipment. Now, just a little bit about that. We're sitting on this Earth, and the Earth is rotating. That's why the stars seem to be rotating in our camera. A little bit more about that. But it's very important for astrophotography that you follow the target as it travels through the sky. So the next problem is that many of the things, as you saw in the previous talk, of the things you want to take a picture of, they're very, very small. So you need some magnification, okay? So you want, to get magnification, you want a long focal length. And that's one of the things David was talking about. The longer your focal length, the greater the magnification. Because you're looking at a smaller part of the sky, filling your sensor with it. But if you get more magnification, you're gathering less light because you're looking at a smaller portion of the sky. So it's almost fighting yourself between getting a long telescope and need more light once you want to make the aperture bigger and bigger. So the ratio between those things is the f-stop of the camera. A small f-stop means less magnification, but a bigger aperture. And a big f-stop is a slow telescope because it's focusing on a little bit of an area. So if you want something that's got high magnification and a big aperture at the same time, you're ending up buying a huge lens for your camera. Those are very expensive. They use great optics in all of them. They usually come with fancy things like autofocus and variable aperture. But a telescope is also a lens. It's got some simpler features. Here's a small telescope. It's actually a pretty fast telescope because it's looking at a wide part of the sky. So it's got a short focal length. It's got a manual focus, so you have to focus, that's okay for astrophotography. That's okay for looking at the night sky because you're always focused at infinity anyways, right? You don't need to zoom in and get focus on something close, so that's okay. And it's always got its full aperture open. There's no mechanism to close the aperture. Well, there's no need for that anyways. I'm always trying to gather as much light as possible. So when you buy a telescope versus a lens for a camera, you're saving a lot of money. This one, what's a Red Cat go for? $500 or something? Not much more than that. So for this telescope, I've taken fantastic images with this telescope. So here is this telescope on this tracker that I've used very successfully to take lots of pictures. The second thing is a minor thing. If you really get into it, you might see that your reds are not as red as they possibly could be. At least with photography, you're seeing color. It's very hard to see colors with your visual, but you'll see in all the pictures on the wall there, you'll see there's lots of color there. And that's because you're gathering a lot more light when you're doing photography than your eye can see. So you can very cheaply take your camera into a camera store and get it modified, because it's got lenses that it's got little filters for normal daylight photography, and they can remove that filter and becomes an astronomy camera, or you can buy a DSLR astronomy camera, depending on how much you get into it. Or you can get a dedicated astronomy camera that looks something like this red thing that's on here, which has basically got the same sensor as in something like this. Generally, you can get ones that are cooled to reduce noise. You can get ones that are not cooled, and you can spend as little or as much as you want to get an astronomy camera, but only if you're getting into the hobby in a serious manner. The other thing you need is maybe a PC, a laptop or something to store the pictures that come off the camera. That's one thing an astronomy camera have to do that the normal camera you don't. So the other thing is sometimes it's hard to find a camera. Okay, I know this is kind of there, but I'm not looking through my optical telescope, so I'm not exactly sure if when I point this thing, is it really pointed at what I'm kind of looking at? And maybe a little spotting scope would help, but really what helps most if you get an equatorial mount. So an equatorial mount that Dave described. And here's an equatorial mount. This is my portable mount, and it's portable because I can lift it up. It's even lighter if I move it and it doesn't have a telescope on it. But you could take something like this camping or what have you. And it's got two axes. One is pointed right at the North Star, and the camera turns around that axis just like it did around this tracker to follow the star as it goes through the night sky. And it also has a second axis which turns it away from the North Pole. So in its rest position, it's looking right at the North Pole, and then it's got little motors that will drive it. So what you do then is you get it's the object that you want to look at in terms of its address in the sky. And the address works a bit like longitude and latitude, but it's not like a plain map. It's got two components to it. One is called right ascension because it sounds pretty good, but it's really the time that a particular object would be highest in the sky. And if you think of that as you can think of that as midnight. So it's basically a time, and the stars would travel around once every day, the time that it'll be highest in the sky. If you know what time zone that you're in, if you know what time it is where you are, then you can say, okay, the actual number refers to Greenwich, England. So if you know how many hours are away from Greenwich, England, then you can figure out when it will be highest in the sky. Or you can figure out where you are on the planet if you know the time and when that is highest, which is why the navigators were after a clock that would work at sea so you could see where you were on the planet. The second address is basically how far away it is, and this is called declination, how far away it is from the North Pole. So that's how an object's address, and an object's address doesn't change very much over our kind of lifetime unless it's a comet or something which is moving through the sky, and planets change their address daily. But most of the objects you're after with astrophotography, they're constant. And you can look it up. If you see a picture, or I've got a book here that I always keep by my side, and I've actually got a few copies of it. Basically, it's got maps of parts of the North Light sky that go for, that you use depending on the date of the year. You can find out what's up in the night sky, and you can see objects that you might take pictures of. Or if you know the name of the object, you look it up and it tells you precisely what the address is. The nice thing about a go-to mount is all those things, a lot of those things are in a little sort of computer. This is a little hand thing. So I can just type my object that I'm after. It knows, I tell it what time it is, where I am on the Earth. It looks in its own little database, and it goes pretty much to it. Okay? So it's much easier to use. So all you need to know with a mount like this is what is the address of what you want to look at. The other thing you'll note is on this scope, on this mount, you'll see there's actually a second scope here. And because I'm looking at things fairly closely over long periods of time, I want this go-to scope. It knows where it's looking at, but I want to make sure it's precisely tracking the object that I'm looking at. What I do, we guide camera on here and a second scope that's just looking at where the stars are and trying to keep that star in a single place. So it sends a signal to this mount and says, okay, move a little bit in right ascension this way, move a little bit, and that keeps your camera focused on what you're taking a picture of. Okay? The other reason you need a tracker is even if this is the most expensive mount you can buy and it knows exactly the angle it's pointing at, the sky itself will bend the light. And so what you're looking at, like looking at a stick in the water or something, it bends, looks like it's bending the stick. Well, the sky is doing that to the stars to various degrees, depending on the weather. And this mount isn't smart enough to know what the weather is. So you need a guider. So this whole kit you can put, requires probably about a few grand anyways to put the whole kit together in terms of the camera and the tripod and the lens. So you have to figure out what your budget is. How far do you want to go with your hobby? Start small and buy more up if you can self-justify or justify it with your family. Sometimes that's the hard part. Do you need an observatory? Maybe. I don't use one. I just use a cover to cover my telescopes up at night. Depends on how secure your telescope is, whether you're comfortable leaving it out at night. And if you've got a simple budget, my recommendation is spend it on the mount. I'm going to show you a couple of much bigger telescopes than this. They're not necessarily better. Okay? The speed of the telescope is important, and the focal length and the speed amount to how much magnification? Well, some things look great close up and you want a lot of magnification, but there's lots of things that look great in a wide field view. So it's not that there's some objects that I must use this scope because I want a wide field view. Not that this one's better than this. This one can, they're both about the same speed actually. And this one can just provides a little bit more magnification. And here it is set up, ready for the nighttime to arrive. And this is a picture I took with this rig of a nebula. And this is one of my favorite pictures that I've ever taken. So last thing I'm talking about is what about sleeping, okay? I need to get sleep. Everyone needs to get sleep. And here's where a bit of tinkering comes in place too. And that is robotifying your rig. So I set mine up in the evening. I can go and watch a TV show. I can go to bed. I can do whatever I want. If I can leave it in my backyard over the next day, put a cover over it, take the cover off at night, start it up, and it'll take several days of imaging. So even the speed of the telescope is not really an issue. You just have to spend more nights taking your picture if you've got a slow telescope. So it was important for this because my portable rig, if I go camping, I might want to take pictures at night. So I won't have full nights to do it with. So really, it does everything that you would do manually. Like I can put a focuser on here, so it will focus for me. I can put a little program in the computer, and here's a little computer that drives this whole thing. And I can remote desktop. I can remotely log on to this computer, and I can control everything from my nice warm inside office, which is really nice in the wintertime when you've got those long nights. You can use the camera to plate solve and sky modeling and frame things like a real photographer would do. Automatic focusing, I said that. The PC can actually improve the guiding. You can have a filter wheel, and there's a filter wheel. There's filters in here on a wheel that you can take get rid of the light pollution caused by a lamp across the street or the moon. Sometimes it shows up too bright. And you can actually get into special narrowband imaging, looking at what kinds of molecules and what kinds of radiation are going on in the sky, and do things like that. You can get it to rotate the camera to frame things nice for you. And if you do have an observatory, you can get it to do that. So here's one of my non-portable. It kind of lives on this patio. It's a much larger refractor than this. And I also have, for really zooming in, I've got a reflector. So it's basically one of these kind of, but mounted on an equatorial mount instead of an alt-az mount. So these are all robotically controlled, and I can control them. So I've talked about some, if you're a classic astrophotographer, you can see the dollar signs coming up, right? Like to get all this stuff. You don't have to do that though, right? There's one alternative is companies are coming out with, and this is a pretty good one. It's got all this stuff in a self-encased in a self-encased thing with very simple program. If you're not into tinkering, this will do everything. You just follow a recipe and it'll take the pictures. It's not the fastest telescope because you can see its aperture isn't very big, but it's about the same size as this rig, and really simple to use. It'll come up on your phone and takes pretty decent pictures. The Sea Star.
The Sea Star is amazing.
Yeah.
It's like, but
Yeah.
there are far more expensive.
Yeah.
Center actually has experiments. That's all.
Yeah. So the difference is and take some nice pictures, and if you've got you want to take some pictures and put them on the wall, or talk to your friends about it, or hear something in the news and you want to take a picture of it, this is fantastic, right? This kind of thing is full on. I'm right into this. This is a major hobby, and it's a major hobby of mine, and obviously, and I probably spend too much, but I like tinkering. I like going after the fun. I am a scientist, so I like going after the fundamental science behind the things that I'm taking a picture of. So it's horses for courses. Oops. The other thing you can do, and this is fairly inexpensive too, is if you're okay with some people operate their telescopes. They put them in Chile, they put them in interesting locations. You can take pictures of things that you can't actually see from here because the Earth's in the way. And you can go on and you can get the very data that these things generate. And you can go and get the data and you do the processing. Right? So if you're a real artistic type and you don't like tinkering with stuff and you don't like doing the hardware side, there's no need to. Right? These guys have hugely expensive telescopes. Now, you may not realize this, but you've already paid for a whole bunch of images that are taken by the JWST and the Hubble telescope. You can get the data from them and you can download that and process them and make the image your own. Crop it the way you want, develop it the way you want with the software, and we've already paid for this with our taxes, so it's free. You just need to go on and download it. There's instructions. There's lots of instructions how to actually get the images taken by those space telescopes. So there's lots of free data out there too. At the end of my presentation, it must be. So whether you're in it, we have a part of the RASC with the astrophotographers. We get together virtually once a month, as well as here and there, and we show each other the images we've taken. We discuss them. We said, oh, I had a problem with this image, getting it to look right. What can I do? And we have a great time talking about that. So it's not just a solitary hobby. We post our pictures online, social media. There's actually astrophotographers, little websites that we post things. It's great fun, and you're learning all the time. So can I answer any questions, or? I think less than $5,000, right? So if you have different telescopes, you don't have to buy everything twice. But yeah. Yeah, I'm afraid my wife might be watching this. It's yes. That's what would you say that was about? $500 or something? Yeah. Seven. Okay. Yeah. Well, less than $1,000.
And then there's more sophisticated Sparrow, Stellar, they're upwards of but this one actually apparently does a pretty nice job.
Yeah.
I mean, you basically just stack them.
Well, another option, and I didn't make a slide about it, is if you join RASC right on the hill here, RASC has some really nice telescopes. You can always join RASC and arrange for a night of astrophotography and get your images that way. And I bought my stuff new. You can get them secondhand for much cheaper than I have to. Photo, you can go, yeah. Well, yeah, there's free options. There's yeah. If you know Photoshop is great, right? Photoshop is a general image processing, and there's something called PixInsight, which is not free, but a lot cheaper than Photoshop. That is specifically for astro images. And I don't think there's anything you can technically do in PixInsight that you can't do in Photoshop. There's some things you can.
It has a lot of stuff. Before PixInsight, it was just and people actually had a lot of scripting routines. A lot of the stretches that take place, like Dave mentioned that things are dark. Well, they truly are dark. If you take these images, all your data is bunched up on one end at the dark end. So you basically have to take that, pull it up, stretch it out. So Photoshop's always been able to do that. There's very smart routines.
The other thing I would recommend, PixInsight is a very different interface. If you're used to using Photoshop, PixInsight is a very different interface. There's a free program called Cyril that has a much more familiar interface, as much more similar to Photoshop. So I would look at that too. Yeah.
You would be okay. If you say Pixel, like it's got scripting and stuff in it. Not that Photoshop doesn't have scripting. It's just that scripting is a hard, whereas Photoshop, it's a fairly uniform interface to do graphical things.
Very welcome.
Great, thank you very much, Dave. It's another talk that's experience. Kristen talk queued up here. She's going to tell you about her favorite little soap. This is her first. So, as I mentioned to her, yeah, I hope you notice that everybody's passionate tonight based on our particular interests. So the other thing you probably put on is we've all had different interests. So we oh, sorry.
Oh,
Just turn that. Hello, hello. Oh, that's me. Okay. So the thing to realize tonight is that we all have different experiences within astronomy, and no one is right because there's one that's right for you. So I kind of find myself in the middle of all this. I'm not loyal to any of these. Like I enjoy visual, I enjoy photography, uh, but some people have a very particular thing. Like Dave likes photography, and it's great because he produces such amazing stuff. So you want people that kind of specialize in a way, and Jill and Brenda have done some amazing things visually, which I really admire because um, part of the beauty of astronomy is the journey that you take when you learn the sky. Because I don't think people really say too much about that. Like a lot of people say, "Oh, we take our telescope out and we saw this, we saw that," but it's more than that. I think for most of us, it's more than that because we're really building kind of a body of knowledge, which is for us. It's our memories of the sky, and it's our skill with finding things in the sky. So I think Kirsten's probably going to tell us a little bit about that too.
Thank you, David. Great. Can everybody hear me okay? I've been a member of the Victoria chapter of RASC, the Royal Astronomical Society of Canada, since last September. I joined September of 2023. And I'm happy to say that one of the main reasons that I joined was I discovered by looking at the RASC website that they offer a number of structured observing programs. And you've heard a lot about those tonight, the Explore the Universe program, which is kind of the entry orientation program that Brenda and Jill talked about. And that was one of my motivations for joining was, and like what David was saying about learning the sky, learning what the constellations are, how they move with the seasons, the major stars, looking at some deep sky objects and this kind of thing. So for the most part, when I started in September, I used binoculars. I actually started out with an 8x10 set that I got at Costco for like $100, and then I was lucky. I was lucky in that the Victoria chapter of RASC last November. I'd only been a member for a couple months, but they had a used equipment sale. And I was lucky in that I managed to purchase for an excellent price a used, really nice set of binoculars, 10x50s, so a little bit more magnification, bit better of a brand than what I got at Costco. The Costco ones were actually fine; they were good. But these were an Orion set from a pretty experienced observer that they're beautiful. They're beautiful binoculars. But I was in this used equipment sale, and I looked across the room and I saw that. And I said, wow, that looks great. It's so small, it's so light, it's so portable. And so I asked, the fellow that was selling it, well, what's it good for? Like, what does it do? And he said, basically, long story short, he said it's a great scope for looking at the moon. So, and then other people kind of in the room chimed in, said, oh, it's a great travel scope, but it's really kind of just good for looking at the moon. So, one of the other RASC programs that I was interested in looking down the road to completing is a much more detailed kind of explore the moon program where, there's a lot of visual observation on a lot of detailed things on the moon. So I thought, well, if that is good for the moon, I thought, one of the advantages of getting a small telescope would be instead of binoculars is your hands aren't shaking. I know for me, with the wide field of view from a binoculars, they're great. But if you're looking at something for an extended period of time, your hands start to shake. And so for me, if I'm going to be sitting or trying to observe the moon for like 30 minutes, I thought that would be great because it won't shake. I can sit. I can be comfortable. So I found a photo online of this 90 millimeter Mac Cas on an equatorial mount. So, just as a side note, when I got it home that night, it was November 27th. It happened to be the night of a full moon. And so I got it out. I got it out on my deck. And I managed, it came with an eyepiece, and I'll talk more about eyepieces momentarily. But I got it out on my deck, and it was the very first time I tried to use a telescope. So I'm out there, it's late, and I'm trying to focus it, but it was a full moon. So fortunately, like, it's an easy object to find. So I was able to actually find it. Took a while to focus it, and one of the things I noticed right away was the full moon filled the entire field of view. Like the eyepiece that I was looking through in that tiny little guy, the moon in great detail just was like immediately right there. So I was thrilled because I knew then at that point that I'd be able to fulfill the program. But then I kind of wondered, well, what is this? What is this scope that I bought? So the next day I started Googling it. And everything's pretty much available on the internet these days. So I just put in its brand name. My particular scope is a Bushnell, which actually quality-wise isn't too bad, but it's comparable to things like Orion or Celestron or that kind of thing. New, they retail for about $350, $400. They're not actually that expensive of a scope. And I found out that it was basically a 90 millimeter. It looks very small and very tiny, but it's like a Schmidt Cassegrain. It's a variation of that kata dioptic system that David was talking about. That's kind of that mix of mirrors and lenses. It's a mix of a refractor and a reflector, and it's just a very specialized kind. And it was made by I guess a Russian or Soviet optician, Dmitry Maksutov, in 1941, and they've been commercially available since the 50s. They're not quite as common as refractors or reflectors or Schmidt Cassegrains because they tend to be pretty specialized, and I'll get into explaining why that is. They're sold mainly in the small sizes, but they're known for their exceptionally sharp images. So I found that mine was a 90 millimeter aperture, 3.5 inches, which is one of the reasons why it's small, with that kind of compact catodioptic structure. But with that, it has a focal length, and you've heard a lot about focal length tonight, but focal length, it's got a long focal length of 1250 millimeters. And you look at that little scope and you kind of think, well, how is it possible to have such a long focal length? And it's to do with the folding of the light between the mirrors and the lenses. It's got a long focal length ratio of 14, which is extremely long and extremely slow. It has came with an eyepiece. It has what's known as an erecting prism or an amici prism, which is really cool, actually. It means that you can look through it and everything is right side up and it's not backwards. And I have to say, even though, you know, with these amici prisms, you apparently lose a bit of quality of image, but I love being able to look at something right side up and the right way around. I just find it particularly, I don't know, orientating, I guess, for me. It's a very tiny little Alt-Az mount, but that's what that is. And it came with a little red dot finder, which is very handy. So the aperture, the light gathering ability, the amount of light that can enter the scope. General rule of thumb, the larger the aperture, the more light gathering ability. Essentially making objects look brighter in the eyepiece, like when you look through it. So aperture is particularly important for distant, deeper sky objects like nebulas and galaxies that are fainter and that need to have their brightness boosted. So brightness decreases as magnification increases. And so there's lots of available information about this, but for me as a learner, these were really important concepts to try to get my mind around, like in the sense of why does something show up nicely like a planet or the moon and something like a galaxy doesn't, right? And this goes to these really important concepts. And I found that as I learned more about this scope and what it could and couldn't do, I kept running across these concepts of focal length and focal ratio all of the time. So focal length is that distance light has to travel from the entry point where, so the aperture of a scope, and this goes for any scope. So the distance that the light has to travel when it enters the aperture of the scope to the exit point, which is essentially the eyepiece, focuser in the case of an optical telescope. So that distance, depending on the configuration of the scope, it's not always a straight line. And in that catodioptic kind of system of lenses and mirrors, it bends and it's reflected and it goes back and forth. So it's not a straight line. So it's a very short, compact looking scope, but that light's going back and forth a whole bunch of different times. And so the long focal length. And every scope operates at a specific focal ratio, which is based on the focal length of the scope divided by its aperture. And what Dave was talking about in his astrophotography presentation, you know, what that focal length is and how fast that scope is going to determine what that scope is best suited for in terms of whether it's good for looking at the moon or planets or galaxies or nebulas or distant objects or closer ones. So there's three general categories of focal ratios, like short and fast, which tend to be like 4s and 5s. Mediums, focal ratios around focal ratios of 6 through to 8, and then long and slow ones, which are f9 and above. The little Mac Cas there is like a 14. So with that, and the reason why focal length and focal ratio is so important is it goes to what you can see in the scope itself. So scopes that have long, slow focal ratios have really high inherent magnification capabilities. But with that comes, and this is kind of not the bane, but, you know, for a beginner in particular, you know, there can be misunderstandings about what, like, even like big apertures don't necessarily equate to big fields of view. Brightness, light gathering is what comes in through the big apertures. What you can actually see at the eyepiece is dependent on different things. So that focal ratio, as well as possible and maximum fields of view, which depend a big part of that on eyepieces. And I'll talk about those shortly, but eyepieces, which are, I don't have one handy, but just, they're a separate thing, an eyepiece, and they go into all kind of optical scopes. You put them in, and that's what you look through. You know, where the light comes in, that's the entry point, this is the exit point. And that eyepiece, the size of it, its field of view, has a massive bearing in terms of what you can actually see in the scope. And so the type of scope you get, the type of eyepieces you have, and the type of focal length, all of those things go in together to help you determine what that scope is actually going to be good for looking at. And so it's a key trade-off, because there isn't one scope that does it all. You know, it would be great if there was, but there wasn't. So, you know, the scope that Brenda has, that big 6-inch reflector with the 6-inch aperture, it gathers lots of light, really good for looking at deep sky stuff. When you compare that to the little 90 millimeter Mat Cas, they're good at very different things. So the smaller one, great for the moon and planets and small pinpoint bright objects like stars. And that's an exceptional telescope for those things, and it resolves double stars really nicely. But it's not recommended for finding or viewing deep sky objects, mostly because it has such a narrow field of view. And when you think about that, like, its inherent field of view, it's less than 1 degree. Like, because of the nature of the eyepiece, some of the eyepieces I have, I think I've lost the pointer. I've managed to increase it, but 1 degree is essentially the size of your pinky finger, if I've got that right, 1 degree. And so inherently, for a scope with a focal ratio of 14, it's about half of my pinky finger would be about what it naturally would have, compared to binoculars, which I'll do this terribly, but the 5 degree field of view is about this much compared to like half my pinky finger. So that's the difference in terms of what you're actually able to see in terms of looking through and finding your way across the sky. So eyepieces, I've learned in this short journey so far that they are as important as the telescope itself. A good eyepiece is, I mean, it's half of the telescope. I know that they're typically considered an accessory, and for sure that they are, but they play a critical role in terms of the quality of what you're going to see, the magnification, and as I probably over emphasizing, but the field of view. I've just personally found that field of view is such an important thing in terms of what that means for your quality of your viewing experience, whether, you know, it's binoculars or scope. It's just such an important consideration. Poor quality eyepieces with a great scope can pretty much, you know, really hinder or affect the viewing experience. So a great quality eyepiece can provide wider fields of view and really comfortable viewing. So you need to know the size of eyepiece that your scope or a scope that you're considering purchasing, whether it takes like 1.25 inches or 2 inches or both. Again, direct correlation to size of eyepiece, focal length of the scope, and what your maximum field of view for any type of scope can be. It's so for my little Mac Cas there, the maximum field of view it can get is about 1.3 degrees, which is, you know, kind of going back to this again, just a little over this. Whereas there's other scopes like I think, you know, wide field refractors that use like really bigger 2-inch eyepieces that have really big fields of inherently built into the eyepiece. You can get to, you know, over degrees of field of view in a telescope, which is a pretty nice thing to have. You know, as a beginner, that's half the battle, is finding your way. I mean, binoculars are great for that. Find your way and star hop around, but it, you know, it's just be that much nicer to have that in a telescope as well. Okay, so pros of a small scope like that, ultralight and portable. I get amazingly clear, detailed views of the moon, like the magnification inherent in that long, slow focal ratio of a scope. Amazing views, great views of the planets, just brilliantly clear. It's great at resolving double stars. It has that erecting prism I talked about, just a kind of personal favorite. Very little to no cool down time, and because it's so little, it just really doesn't need any collimation, just despite being kind of a Schmidt-Cassegrain type of setup. But again, going back to that really narrow field of view, so I've got to know what I've got to know what I'm looking at almost exactly, so I can on it, and you know, because it's just so narrow. I'm limited to the 1.25 eyepieces. It's really not good for finding and observing deep sky objects. And yeah, I've got kind of an interesting mount. It works, but definitely one of my first things I need to upgrade to is a really nice mount. So key takeaways, just figuring out what you want to find and observe. Like, there is no such thing as a one-size-fits-all telescope. I mean, I think, in my view, there are scope configurations that are more versatile than others. This is a very specialized scope, so versatility is probably not its main attributes, but for what it was built to do, really good at. But once you know what you're interested in looking at, if you're mostly interested in galaxies, nebula, and deep sky stuff, having the bigger aperture to collect that light is really, really important. But while aperture is key and important, so is portability and ease of use. Like, I know for me, like a 6-inch Dob or an 8-inch, I mean, it's just, you know, you gotta want to use it. You know, you gotta be able to take it down the stairs and get it in the vehicle and all that kind of stuff. And it's so you gotta know what you're gonna use. The importance of focal ratio and why that's actually, you know, it's important, what it means for magnifications, brightness, and field of view, the importance of eyepieces and that them being half the scope, and the importance of a good mount. So that's the end. Any questions at all, or?